Hello, I am Ravi Vasudevan, and I will be your lecturer for the next block of videos, where you will learn about maximum power point tracking, cables, and batteries. Here, I am going to explain the concept of maximum power point tracking, or Mppt. This is very important to understand as a photovoltaic systems engineer. In this video, I will introduce the concept to you so that you can understand what Mppt is and why we use it. But before we get into what and why, let's first talk about where. Here you see the familiar layout of components of a PV system. Maximum power point tracking usually happens in the charge controller or the inverter. Later, I will explain how these components actually perform maximum power point tracking, but for now, you can just remember that these are the components that contain the logic for Mppt. But why do we need to track the maximum power point? Here, you can see the familiar IV curve of a solar cell or solar module. You should know by now that power can be calculated as the product of current and voltage. We can therefore easily plot the power voltage curve. From this curve, it is simple to see that a maximum power point is present. This maximum corresponds to a certain voltage, which we call Vmpp, and a current, which we call Impp. So, in order to operate the solar cell optimally, we have to try and operate at this point. One way to view an illuminated solar panel is a voltage-controlled current source. Therefore, we want to apply a voltage equal to or close to Vmpp to our solar panel. If the voltage is at Vmpp, then we can be assured that Impp will be delivered by the solar cell, and that means that maximum power is being delivered from the solar cell. But does this always happen? Let's start by making a very simple circuit with a solar panel. In the upper right side of the slide, you can see that we have simply connected a resistor to the solar cell. Well, we know that the current across a resistor has to equal the voltage divided by the resistance from Ohm's law. Therefore, the IV curve of that resistor will be a straight line with a slope equal to the inverse of its resistance. Let's select an ideal resistor for this given solar panel. Now we can see that the resistance crosses the IV curve of the solar panel at exactly its maximum power point. This is great. This means that the solar panel will deliver as much power as it can to the load. However, what happens if the irradiance were to change? From this plot, you can see that the resistor would stay the same. However, that means that it would operate on a different part of the IV curve than its maximum power point. You can probably imagine that there is a different load that would work ideally for each given irradiance, but it would be impossible to design a system such that the resistance changes whenever the system requires it. In fact, you could easily imagine that the load would change depending on what the user wants to do. If this happens, the solar panel would also rarely operate at its maximum power point. So now you see the first important aspect of maximum power point tracking, namely the decoupling of the load voltage from the PV voltage. As PV system designers, we always want the voltage at the PV side to be the Mpp voltage. The load should be independent, whether it is a battery, some simple devices, or the grid. We will do this using power electronics, and you will learn more about that in other videos during this course. Just keep in mind that the PV voltage and the load voltage need to be isolated. So that's all well and good, but how do we go about actually finding the maximum power point voltage? It is really simple to just look at that plot and determine the best voltage, but how do we do this while the PV system is running? What if the irradiance level changes or some particular shading to our PV panels occur? Can we dynamically figure out that Vmpp value? It turns out that there are many ways to do this, and through the coming videos, we will be examining many of them. However, they all use the same basic principle. That is, a certain parameter value from the system is used as an input, and through some sort of logic, the Mpp voltage is calculated. Then, using power electronics, the system will apply this calculated voltage to the PV panels, and they will then be operating at their maximum power points. This input could be from either the PV side or the load side, or it could even be something about the ambient conditions that will help us to calculate the input. Also important to realize is that the calculated voltage applied to PV isn't always equal to exactly the VMPP. Accuracy will depend on the algorithm used, but all of them are trying to calculate this as best as possible. So as a concluding comment, I'd like to wrap up this video by making sure that you get the main point regarding maximum power point tracking. The most important aspect of Mppt in a PV system is decoupling the load voltage from the PV voltage. This is necessary so that we can obtain the maximum power from the solar cell by operating it at maximum power point voltages. In the next video, we will look at the different ways to calculate this VMPP value.